Hello and welcome to the next episode of my tutorial series, Keyboard and Theory Basics on Synthesizers. In this episode, we're going to be talking about the circle of fifths. Before we get into that, I'll just go back over what we've already talked about so far. So far, we've talked about the keys, the names of the keys, the concept of a key signature, the concept of a time signature and rhythm. We've improvised on one note. We've discussed scales, we've introduced the pentatonic scales, and we've improvised on the pentatonic scales. We've discussed the concept of major and minor. In this episode, we're going to introduce probably the most important concept in music theory, something that really made a big difference to me, and that is the circle of fifths. So what is, first, a fifth? Well, a fifth is an interval which consists of a gap of 7 chromatic steps. 1, 2, 3, 4, 5, 6, 7. You may ask yourself, well, why is this important? Well, the reason it's important is a full octave, that's a doubling of frequency, is made of 12 steps. Going up to this key, it takes 7 steps. Going down to this key, it takes 5 steps. Both of those numbers are co-prime with 12. That means they share no common factors. So if we ascend in fifths, we are going to go through all of the 12 chromatic notes, which is good and it's important for the way that we're working. More than it being important, a fifth is the strongest interval other than the octave on the keyboard. Well, why is that? When we have a sound at a fundamental pitch, and then there are frequencies which are integer multiples of that pitch known as harmonics. The first harmonic is at the root pitch, the second is at double the frequency or the octave. We've mentioned that octaves are musically equivalent. The third harmonic is at 3 times the pitch. This is the first interval which is not the same note as we started with. It is equivalent to effectively the fifth octave above. So this is the first harmonic, this is the second harmonic, this is the third harmonic. In reality, this isn't actually the third harmonic. Because of equal temperament scaling, this is only close to the third harmonic, but it's pretty close to the third harmonic. So, harmonically, the fifth is the strongest note associated with another note. So one of the things that we could do is we could ascend the keyboard going up in fifths. C, G, D, A, etc. So each of those is an interval of a fifth. And because a fifth is a strong interval, it is closely harmonically related, then you could consider a sequence of notes that are a fifth apart to be strongly related to one another. We have a way of representing this scale of fifths in a circle called the circle of fifths, which looks like this. Now, you may not have seen it like this before. Why? Well, firstly, I have included all of the notes with more than one name. So I've called B sharp C, and I've called E F flat. So I've included all the ambiguous naming, and secondly, I chose to start it at D at the top. Conventionally, people place C at the top. Well, why did I choose to put D at the top? Firstly, I hope you can see the symmetry here. There are 3 notes at the top that don't have ambiguous names, and all of the rest of them do. You can imagine if C was at the top, then it wouldn't have this same symmetry. The symmetry of this diagram actually reflects the symmetry of the keyboard. Well, you look at the keyboard and you say, in what sense is this symmetric? I mean, we have these intervals C to C, there's no symmetry there. Well, consider this. We start at D and we're going to move out chromatically 1 step at a time. White key, black key, white key, white key, black, white, black, white, black, white, white. So you see that the arrangement of the notes on the keyboard is actually symmetric around D, and this continues for the entire piano keyboard, except that it ends at a C and it starts at an A, which is not actually symmetric around D. So there are a few notes either end, but the majority of a full-size piano keyboard has this symmetry. So I appreciate the symmetry in placing D at the top of the circle of fifths. So why is the circle of fifths important? Well, let's use it to investigate a scale that we know well, the C major scale. What notes are in the C major scale? C, D, E, F, G, A, B. So though they don't appear in order, we can see that there is a 7-note arc going around the circle of fifths which corresponds to the notes in the C major scale. Let's look at the C minor scale now. The C minor scale we know contains C, D, E flat, F, G, A flat, B flat. So again, we have a continuous arc of notes on the circle of fifth corresponding to the 7 notes of the C minor scale. We can repeat this process for any of the scales. So let's look at the A minor scale. What's in the A minor scale? A, B, C, D, E, F, G. So again, we have a continuous arc all the way between B and F on the circle of fifths representing the A minor scale. This is not a coincidence. This is exactly how every scale from the traditional 7-note Western scales are structured. They are a continuous arc of 7 notes on the circle of fifths. But it's stronger than that. Let's look at C major again. So we have C, D, E, F, G, A, B. So how many notes in the anti-clockwise direction did we include from the C? We included 1, which is F. How many notes in the clockwise direction? 1, 2, 3, 4, 5. So we included C, we included 1 note in the anti-clockwise direction, and we included 5 notes in the clockwise direction. Let's think about another scale which we've seen before. The scale that we've seen before is the D scale. Actually, G major. So G major, we know that G major is made of G, A, B, C, D, E, F sharp, G. So let's start at G. 1 note counterclockwise is C. So C's in the scale, C, G. Now 5 notes clockwise, D, A, E, B, F sharp. So here we have it. G, A, B, C, D, E, F sharp. So using the same method of saying, starting at a root note, going 1 note counterclockwise, and 5 notes clockwise, we are able to locate all of the notes that are contained within that scale. This is equally applicable to any of the scales. So let's take a minor scale, let's say F minor. So what have we got? We know what the F minor scale looks like. We know it contains F, G, A flat, B flat, C, D flat, E flat. So what have we got? F, G, F, G, A flat, B flat, C, D flat, E flat. So you may have noticed another pattern here. When we have a certain arc, we take every second note. Why do we take every second note? Well, because when you jump up a fifth in a certain octave, you remain in that octave. So from the C, going up, we hit the G. Now when we talk about notes, we'd like them to be in the same octave. We've got D, this is going to go back down, and then we've got A goes to E goes to B. So this is our C scale. Those are the fifths that we traversed. But the question to ask yourself is, why do they appear as every second note? Well, that is because when you go up a fifth, you're going away from the note that you started. But when you add a fifth to another fifth, well, now you've got 14 chromatic steps, which is 12 chromatic steps of an octave plus 2 more. So when you take 2 jumps along the circle of fifths, you make your way to the next note. Given that we're looking at an interval of 7 notes, when we come to the end, we want to go back to the beginning. So let's take C major as an example again. Well, we know we're going to include 1, 2, 3, 4, 5 notes afterwards. So this is where our scale is going to end. So we've got C, skip 1, D, skip 1, E. Now we've got to skip that B, and we're on the F. Skip 1, G, skip 1, A, skip 1, B, and we've completed our scale. So this process of finding the order of the notes works every time, and it works whether the key is major or minor. Jumping back to the F minor key that I was talking about, well, we said we've got F, G, A flat, B flat, C, D flat, E flat. So let's look at how many notes in the counterclockwise direction that were part of the scale. 1, 2, 3, 4. So we've got 4 plus 1, there are 7 in total, so we've got 2 in the clockwise direction. So to construct a minor scale, we take 4 notes in the counterclockwise direction on the circle of fifths and 2 notes in the clockwise direction. So notice for major it's 1 and 5. For minor it's 4 and 2. Let's try it on another scale we know. A. We know about A. For A, we're going to go 1, 2, 3, 4. So this is one end of our A scale, and we're going to go 2 clockwise. This is the other end of our A scale. So you can see we have included all of the notes, and following the every second note rule, A to B, B is at the end of our interval, so we're going to skip the F and it's C, skip the G and it's D, skip the D and it's E, skip the B, we're around to F, skip the C, we're up to G. We've made it all the way around the scale. So we've come up with a rule that for the circle of fifths, we can read the notes that a scale will contain, but we can do more than that. You may have heard the rule that in order to convert a major scale to a minor scale, you're subtracting 3 sharps or you are adding 3 flats. So conventionally, when looking at this scale going counterclockwise, I've mentioned that I included the ambiguous namings of these notes. The ambiguously named notes can add a little confusion, so let's ignore these, the C and F, which are also white keys, and let's look at the flats. Remember I mentioned when a key signature has 1 flat, it's B flat. When it has 2, you add E flat. When it has 3, you add A flat. 4, you add D flat. 5, you add G flat, and so on around the scale. So think about this. We're looking at the scale of C. In the major case, we go 1 note in the counterclockwise direction and 5 notes in the clockwise direction. In the minor case, we go 4 notes in the counterclockwise direction and 2 notes in the clockwise direction. The counterclockwise direction is where we start to see the flats. So what's happening here is we are shifting the interval that we think of. This is the interval corresponding to C major. We go 1, 2, 3, and now we're on C minor. So you may ask yourself, what's special about the number 3? The answer is that there's nothing special about the number 3. We could choose to move that interval any number of steps as long as the root, in this case C, remains in the scale. So let's consider what that means to us? Well, the circle of fifths has an interesting property. When you proceed around it in the clockwise direction, you come to notes which relate to the note you started with and feel bright with respect to that note. If you go around in the counterclockwise direction, you move to notes which seem dark with respect to that note. So when we see the minor scale and we see that it includes 4 notes in the counterclockwise direction, we could say it is a darker scale than the major scale, which only includes 1 note in the counterclockwise direction. But what's special about the numbers 4 and 1? Nothing whatsoever is special about those numbers. So we have a whole family of possible scales, specifically 7 scales, that we can consider, which will range in brightness or darkness. And those scales can be considered in 2 possible ways, and they are known as modes. So I'm going to jump to the keyboard and I'm going to talk a little about modes. And then, having spoken about modes, I'm going to come back to the circle of fifths and show you how it explains them to you. So we've spoken about the concept of relative scales and parallel scales before. So the modes, as they are described, are often considered to be relative scales to another scale. A relative scale means it uses the same notes, but it has a different root pitch. So what we've seen before is that C major and A minor are relative scales. In other words, they use the same note, but they have a different root. The truth is that we could use those same notes and we could start on any one of the white keys. So let's see what it sounds like. Let's start on C. That's commonly called the C minor scale, the C major scale. Let's start on D. That's commonly called the D Dorian scale, the E Phrygian scale, the F Lydian scale, the G Mixolydian scale, the A minor scale. Minor is also called Aeolian, major is also called Ionian, and finally the B Locrian scale. So that was a way of looking at modes as starting at different points in the scale, but it turns out we can also make parallel scales. In other words, scales with the same root, but representing the different modes. So how do these work? Well, let's jump back to the circle of fifths and think about it for a minute. Given that we know a scale is a continuous block of 7 notes, and one of them is the root, we can choose to place the root in the first position, the second position, the third position, the fourth position, the fifth position, the sixth position, or the 7th position. And depending which position we place it, we end up with more notes in the counterclockwise direction, in other words, more dark notes, or more notes in the clockwise direction, in other words, more bright notes. And it is no coincidence that these relate to those modal scales I was just playing. So let's start with no notes in the counterclockwise direction, only notes in the clockwise direction. There are 7 notes in the scale, so what have we got? C, G, D, A, E, B, F sharp. Okay, so this is the brightest of the scales that we have access to. Why? Because it includes the most notes in the clockwise direction. So that is 1 sharp. And remember I said if a key signature has 1 sharp, it is F sharp. Let's now include 1 in the counterclockwise direction. Well, we already know that corresponds to the major key or the Ionian mode. Now let's include 2 notes in the counterclockwise direction. So we get C, D, E, F, G, A, B flat. So we've included 1 flat in our key signature. So we had 1 sharp, No sharps or flats, 1 flat. You can imagine to rotate it further, it's 2 flats, it's 3 flats, it's 4 flats, and it's 5 flats. And that motion of having a scale, adding 1 sharp turns it into a major scale, adding 1 sharp turns it into a brighter scale, adding 1 flat makes it darker, 2 flats makes it darker, 3 flats makes it even darker, that's the minor scale, 4 flats makes it darker, 5 flats makes it even darker. So this gives us a spectrum of possible scales, not just major, not just minor, but an entire spectrum of notes that lies within those. So let me play those scales for you. So let's start with the brightest of those scales, which includes 1 sharp. That scale is commonly called the C Lydian scale. So the Lydian mode, if I just played white notes, would start on F. So this is F Lydian. That is F Lydian, which is a relative mode to C major. And then this is C Lydian. C Lydian being the parallel scale. We've already covered major. So there is no parallel major to a major because it's already major, although you could say C Ionian is the parallel mode, but it is the same notes. So now let's introduce 1 flat. So this is making things a little bit darker. And what is this note mode called? This is known as the Mixolydian scale. So Mixolydian is slightly darker. Let's go to G and play. That is G Mixolydian. That is the relative mode to C major, and this is C Mixolydian. So hopefully you can hear it's got a little bit darker. I'm going to stop jumping back and forth between the relative and parallel scales and just play the parallel scales. That was 1 flat Mixolydian. Now 2 flats is known as Dorian. D is the relative scale. Next is going to be Aeolian, also known as minor. A is the relative. The next one is going to be 3 flats. It's going to correspond to E, the Phrygian mode. Whoops. Finally, we're going to play 5 flats, which corresponds to B, the Locrian mode. I played the wrong note there. So, we have played the parallel scales corresponding to all 7 modes. So in other words, we have created a spectrum of different scales, each brighter or darker than the last. And this gives us a lot of power because we're not tied to just the major scale and just the minor scale. And when we talk about harmony, you'll discover that from a modal scale perspective, you can often borrow a chord from a scale which is 1 step brighter or 1 step darker than the scale that you're working in. So this is a very powerful technique called modal borrowing. So we've been talking about 7-note scales, but we've also improvised on the pentatonic scales. It turns out that pentatonics can be modal as well. So let's look at a pentatonic scale. Let's start at C and let's go 1, 2, 3, 4, 5. So what have we got? C, D, E, G, A. So that is exactly what I described previously as the C major pentatonic scale. Now we'll also remember that the C minor pentatonic scale included E flat, B flat, F, G. So that's 1, 2, 3, 4, 5. So this is a C minor pentatonic. So to make the major pentatonic, we add 4 notes in the clockwise direction. To make the minor pentatonic, we add 3 notes in the counterclockwise direction, 1 note in the clockwise direction. And just as we've seen previously, it is possible for us to construct not just those 2, but any of the 5 possible modal scales. Rather than going through all of these, it's a little bit dry, but it hopefully suffices to say that if you were playing in modal music, just like when playing in a major scale, you could choose to stick to the pentatonic. You could do that for any of the modes. So if someone says, we're playing in G Dorian, well, you can play the corresponding, what I would call G Dorian pentatonic. So let's have a look at that. What is the G Dorian pentatonic? So firstly, how do we convert a G major scale into a G Dorian scale? Well, G major has 1 sharp. We saw that Dorian adds 2 flats. So it's not as dark as minor, but it is darker than Mixolydian. So what does that mean? Well, instead of 1 sharp, we subtract 1 sharp when we add a flat, and we add a flat. So what have we got? So that was the G Dorian scale. So now which notes are included in the pentatonic? Well, we could go look at the diagram that we have, but I happen to know that it is so this is now the G Dorian pentatonic scale. This is not how everyone calls it, and personally I would prefer, instead of calling them by these esoteric names, we just call them the first mode meaning the brightest, the second mode meaning a bit darker, and so forth, but that's not how it's done. So you can see then that we've constructed a scale that corresponds to a pentatonic of a modal scale, and this can all be done from the circle of fifths. So my suggestion to you is, now we know that in order to make, say, a Phrygian scale, we have to add 4 flats instead of 3 to a major scale. You can experiment creating these scales. So say we know that F contains 1 flat, this is F major. So we can choose to add 4 flats to that. So how many flats? It had 1. Add 4 flats, now we've got 5. So that is the F Phrygian scale. And it's relatively straightforward to construct these things on the fly. So now we've spent a little bit of time talking about this, let's play an improvisation, and let's play an improvisation in, let's say, the C Mixolydian scale. So Mixolydian is 1 flat added to the major scale. C has no flats, so this is Mixolydian. So that is the C Mixolydian scale. And now we want to know the notes that are included. Now we could jump back to our diagram, but I know it's... Okay, so those are the pentatonic notes, and these are the other 2 notes in the scale. So let's try and improvise. Okay, so we looked at the circle of fifths, we discussed major and minor scales, we discussed that there's actually a whole spectrum of scales called modes. We looked at pentatonic scales. In that case, you could see I improvised on a pentatonic mode, and I used occasionally the other notes in the corresponding modal scale. And it gave us a different tone, a different timbre to just playing in the C major scale or just playing in the C minor scale. So hopefully this lets you realize that there are a spectrum of bright and dark sounds accessible to you, and that you can fairly easily construct those if you bear in mind the circle of fifths. Now in practice, I don't spend my time looking at the circle of fifths. Why? Because on most of these scales, I've played them frequently enough that I simply know how to construct them, and I know the notes that they contain. And as I've said previously, a lot of what playing keyboard is about, it's not about mathematically figuring out the notes that are contained in the scale. For example, somebody may have said to you, oh, to convert a scale into its corresponding flat, so to convert a D major to a D flat major, you have to add 7 flats. Well, why is that? 1, 2, 3, 4, 5, 6, 7. Well, the D flat is 7 in the counterclockwise direction from D. So you had to add 7. What if we need to convert D into D sharp? Well, 7 sharps. 1, 2, 3, 4, 5, 6, 7. Indeed, D sharp is 7 steps around the circle of fifths. So these magic numbers you may have heard, 3 flats for minor, plus 7 sharps for a sharp scale, plus 7 flats for a flat scale. They all live in the circle of fifths, but in reality it comes down to practice, and it comes down to developing familiarity and feel. So in any case, this was quite a long video. This covered quite a lot of theory, but I hope it was illuminating. I hope it was interesting. I hope you will come back and join me for some more videos in this series, but in any case, I'd like to say thank you for watching and goodbye.